Okay, hello. So today we're looking at the final lesson from Unit 3, where we're talking about linear and quadratic systems. Now, a system is just more than one equation. It just means you're dealing with more than one equation at a time. So if you think back to grade 9 and 10, when you did linear systems, a linear system was two lines, and often you were trying to find where they intersect. Here, you're not doing two lines, you're doing one line and one quadratic. So this here is a really good sort of demonstration of the possibilities, almost all of them. You can see that it's possible that a quadratic and a line never actually meet. It's possible that a quadratic meets a line exactly once. It's also possible that a quadratic meets a line twice. Now, the picture here, the one in the middle, it's saying that there's one solution because the line just touches the parabola's vertex. That is true. However, it's also possible to draw a quadratic. Let's maybe flatten this one out a bit. And then let's say 4x, what would this be? Minus 4. It's also possible, right, that you have a line that just has the perfect slope at the perfect point so that it only actually touches the graph once, as it does here in my picture. So the reason I just want you to think about this is because the picture on the page gives you the impression that if it has one solution, it's at the vertex. Not necessarily true. It's possible to have one solution, right? So if I type intersect f and g, intersect, right? It only comes up with one answer because they only intersect in that one place, and that place is not the vertex. This line, by the way, what we call this line, we call this line a tangent. A tangent is a line that intersects a curve at exactly one spot. So anyway, I mean, you don't need to know that about a tangent, but just so you know for the future. It is possible to have one solution of your linear quadratic system and it not be at the vertex. That's the only point I wanted to make. So what are we going to do here? To determine how they intersect, what we are going to do is we are going to replace the f of x with the linear function. So in other words, we're going to set them equal to each other. We're going to create a related equation and then solve the related equation. And the solution to that related equation will be the x values that we need in order to get the answer. So let's try this as a first one. I think this is a good type of thing where you can just sort of jump right into it. So we say f of x is x squared minus 4x. Obviously this is the quadratic, and the other one is the line. Now, where they intersect, right? Well, they have to intersect at a y value that is the same. So what we do is we set the two equations equal to each other. When whatever x makes the two equations equal to each other will be a point of intersection. So any x value that makes the two equations equal will correspond to a point of intersection. Okay, so we set the two equations equal to each other. So in other words, we did f of x equals g of x, right? Set them equal. And now, of course, to solve a quadratic, I can't just solve it like this. I need to bring everything to one side, right? I bring everything to one side, and now one side is 0, and I can try to factor it. I notice that x minus 1 and x minus 5 work in terms of factoring this, and so x equals 1 and x equals 5 should solve the equation. Okay, now just to be clear, we could check this, right? So let's if we sub in 1, for example, f of 1 is equal to 1 squared minus 4 times 1, which is equal to negative 3. G of 1 is equal to 2 times 1 minus 5, which is also equal to negative 3. Of course, they should be the same if this works. Therefore, 1, negative 3 is a point of intersection. Okay, so 1, negative 3 if I draw that here, let's just go back, and I'm expecting these two things to run through one another here at 1 and -3. It should be one place where they go through each other. The other place they should go through each other is at f of 5, which is equal to 5 squared minus 4 times 5, which is 25 minus 20, or just 5. G of 5 is 2 times 5, take away 5, which is 10 take away 5, which is also 5. Therefore, 5, 5 is a point of intersection. And so what I'm expecting is that these two things will cross each other at 1, -3, and at 5, 5. Okay? So now we're going to draw them. So let's draw x squared minus 4x, that's f. Okay, so far so good. At least my quadratic goes through those 2 points. That's a good start. My second g of x is 2x minus 5. Okay, and you can see that I've managed to find the 2 places where these two things intersect. Now, the significance of the numbers 1 and 5 is that they are the solutions to the related equation. The related equation for us was x squared minus 4x minus 2x plus 5, right? And if we just simplify this a little bit, clean it up, we'll get the thing that we actually solved, right? X squared minus 6x plus 5. That's what I actually solved in order to get the answer to the question, right? So this is the related equation that we need to solve. The related equation, all that means is just one side is equal to 0, right? It just means we moved everything over. But I don't want you to find the x-intercepts of the original parabola. That isn't going to help you. You need to take the original parabola, subtract the line so that everything is on one side, and then you find the x-intercepts of your other thing. And if you look here, the x-intercepts are at 1, 0 and at 5, 0, which, you know, the x values of those x-intercepts are going to be the x values of my points of intersection. So it's not difficult to do, but it is a little, you can get lost here if you're not quite clear on the steps. So again, let's just make sure we go through the steps here and we have them written down. Okay, so number 1, set f of x equal to g of x. Bring everything to one side. Let's just make a new page here so we have a bit more room to write this. Bring everything to one side so that you have a related quadratic equals 0. Solve the equation. Find 0, 1, or 2 x values. Sub in those x values into f of x and g of x to find the y values of the points of intersection. Okay? So x value, and again, there may be, of course, if there are no x values, then you just say they don't intersect one another. But if you get 1 or if you get 2, sub them back into f to get the y value, and then check your work by subbing them into g. Again, it's the kind of work that you should know 100% if it's right before you are finished. Okay, now, the next question says, determine the number of points of intersection between f and g, but don't solve. So in other words, all they want to know is, do they intersect once, twice, or never, right? Is there a way that we could figure that out without solving? So what we're going to do is the same process. We're going to set f of x equal to g of x. So we'll go 3x squared plus 12x plus 14 is equal to 2x minus 8. Then we're going to go ahead and bring it over. So positive 12 take away 2 becomes positive 10. Positive 14 plus 8 becomes plus 22. And we have that is equal to 0. Now the question is, how many solutions does this quadratic have? We could figure this out if we knew the discriminant from the other lesson, right? A is 3, B is 10, and C is 22. So if you remember, the thing that we need to do in order to figure out how many solutions there are is we need to check the discriminant. The discriminant, remember, is b squared minus 4ac. What we are wondering is it positive, is it negative, or is it 0?
If it's positive, there are 2 answers. If it's negative, there are 0 answers. If it's 0, there's 1 answer, right? That's what we learned about the discriminant in the previous lessons. You can go back to that one if you need to review how that works. In this case, what we're going to do is we're going to go 10 squared minus 4 times 3 times 22, and 10 squared is 100, and then I can look at 12 times 22. Well, obviously 12 times 22 is going to be bigger than 100 because 100 is 10 times 10, and now I'm taking two numbers that are both bigger than 10 and multiplying them. 12 times 22, we get 264. So we get 100 minus 264 is equal to negative 164. Negative 164 is less than 0, i.e. it's a negative number, right, of course. Therefore, there are no solutions to the related equation, and there are no points of intersection. In other words, these two things never meet. So let's draw them and confirm what we just did. So we'll start a new one here. So we'll go f of x is 3x squared plus 12x plus 14, and g of x is 2x minus 8. Okay, and if you look at these two, you realize that the quadratic rises much faster than the line, so they're never going to meet in the future, and they don't meet around this area either, right? So you can zoom this out and you can see, yeah, they're just never going to cross one another, right? So there are 0 solutions, and these two things never meet. There are no points of intersection. Again, I don't actually need to solve the equation to figure that out. I could just use the discriminant to figure out how many solutions there are. Since the discriminant gives me a negative number, I know there are no solutions and there are no points of intersection. Okay, there's one more question here, and then I want to do the assignment question with you, just because I think this is a bit, I mean, I don't think it's hard, but I think it would be good to show you an example, and then you can try it on your own. Anyway, let's do this skydiver one first. So it says a skydiver jumped from an airplane, fell freely for several seconds before releasing her parachute. Her height in meters above the ground is given by this equation before she released the parachute, and then this equation after she released the parachute. The question is, when did she release the parachute? So you can imagine she's falling in a quadratic way until a certain time, and then she starts to fall in a linear way. And obviously the moment where those two things meet is going to be the moment when she released her parachute. So let's write down, she releases her parachute where the quadratic free fall meets the linear parachute fall, right? So we want to find the point of intersection between the two equations. So we need to find the point of intersection. Actually, to answer the question, all we really need is the x value, although I think the b is, we're going to need the y value for b anyway. So what would we do? We take let's call it h1 of t, which is negative 4.9 t squared plus 5,000. We'll say h2 of t is equal to negative 4t plus 4,000, and then we're going to say h1t is equal to h2. Okay, so the first height is equal to the second height. We're going to find the points of intersection. So let's do that. Negative 4.9 t squared plus 5,000 equals negative 4t plus 4,000. So let's bring everything over to one side. Negative 4t squared plus 4t plus 1,000 is equal to 0, right? That would be the equation that we're solving here, because the negative 4t from the right side comes over as a positive, the 4,000 comes over as a negative and reduces it as follows. This doesn't look like it's factorable to me, so let's take a note of its numbers and do the quadratic formula. Okay, so b is 4, a is negative 4.9, c is 1,000. The time, remember there could be two times, the time is equal to b squared, negative b plus or minus square root b squared minus 4ac over 2a, right? That's what we need to do. So what we're going to do is plug all that in, see what we get. So let's replace the b. You see there's I'm not replacing the negative, I'm leaving the negative sign alone. I'm just replacing where I saw b with a 4.
I'm replacing A with a negative 4.9. Replacing this B with a 4. Okay, this A is a negative 4.9, and this C replaces with 1,000. Okay, and that's the equation that we need to solve, or that we need to evaluate, I guess. Okay, so 4 squared I know is 16. Negative 4 up front we can just call negative 4. On the bottom we can say negative 9.8. Okay, so negative 4 times negative 4.9 is going to be 19.6, but it's going to be positive because they're both a negative number, right? So then I can go 19.6 times 1,000 is 19,600, and then I can add 16 to it, and I get 19,616. Now let's go ahead and do the exact value here, since we might as well practice it in the note. 19,616 could be divided by 2, right? So let's just do this. 19,616 divided by 2 gives me 9,808. 9,808 can be divided by 2, which is 4,904. 4,904 can be divided by 2, and you get 2,452. That can also be divided by 2. Okay, so see, we get 1,226. That can be divided by 2. We get 613. Now, I don't know what can go into 613, so let's test a few things. 613 divided by 3 doesn't work. Divide by 5 obviously won't work, so E divided by, what about 7? Nope. 11? Nope. And 13? I don't think so. So what I think we're going to leave it as 613 here. Let's just quickly do GeoGebra can actually solve this for us. We're going to do prime factors of 613, and it's only 613. So 613 is a prime number itself. So how many 2's did I take out? 1, 2, 3, 4, 5. So what I'm going to do here, I'm going to take one set of 2's to the front, another set of 2's to the front, and then I couldn't take the last one, so I have to leave it underneath. So I end up with 4 times square root 1226. Okay, and 4 times square root 1226 is the same thing as, this is the simplified version. The simplified version of the big root we had before, 19,616. Okay, let's just double check that. So we go square root 19,616, and then we're going to do square root 1226 but times 4, and we get the same number, right? So, it's perfectly the same value. Okay, so we've managed to reduce the root as much as we could, and now let's go back to the answer. So we're going to get t equals negative 4 plus or minus 4 square root 1226, all divided by negative 9.8. Now from this point, there's not really much you can do to make this any simpler. You could factor out a 4 from the top, but I don't really think it's worthwhile. Let's just get the calculator to tell us the answer from here. So let's start with negative 4 plus square root 19,616 divided by negative 9.8. Okay, it gives us negative 13.883. Oops, sorry. Just copy this so I'm not typing it over and over again. Okay, so negative 13.88 is one answer. Go to the other answer.
negative 4 minus 4 root 1226 divided by negative 9.8. And in that case, we're going to get negative 4 minus 4 square root 1226 divided by negative 9.8. And we get 14.699. Now, I think I might have made an error here, 6997. I think I might have made an error in this one. I just want to check the work again. Oh, okay, looks all right. All right, so now there are two possibilities. Either she opens the parachute at negative 13 seconds. Of course, we're going to reject this one as outside the domain. The domain in this question is t greater than equal to 0 because the moment she jumps out of the plane, t is 0. This equation would suggest that she was rising into the air before she jumped, which is probably not true, right? Probably the plane was flying at a steady altitude. So the model really isn't any good before t equals 0. We're just going to keep it after t equals 0. So we're going to keep this one. She jumped, so she released her parachute at 14.6997 seconds. Now, let's check here to see if I did this right. So of course, I could use GeoGebra to see if I did it right, but let's check if we did it right the way you would do it on a test. How would I know if I got this right on a test? Well, I go down to question B, and the question is, how high is she above the ground at this time? So what if we were to check H1 of 14.6997, right? What if we sub this in to the quadratic and actually see what it tells us? What height was she supposed to be at this time? So negative 4.9 t squared plus 5,000. So I'm going to plug it in. 4.9, 14.6997 squared plus 5,000. Now what do you get when you put that in? So I'm just going to make the equation here. So get the number. So negative 4.9. So h of x is negative 4.9x squared plus 5,000, and then I'm going to sub in 14.6997. Okay, and what it tells me is that it's 3,941.2 meters at this time. 3,941.2 meters above the ground. Okay, so far so good. Now, to check if I did this right, what I want to know is, does the other function agree with that same time? So let's plug it into H2 now and see what we get. So we get negative 4 times this number, 6997, plus 4,000. Okay, and what happens when we sub in this? So negative 4, so I'm just going to call this one G, negative 4x plus 4,000, and we're going to sub in G of 14.6997, and you can see that the number it gets is the exact same. 3941.2 meters above the ground. Since the two functions agree, I know I must have done this right. Okay, so let's say she releases her parachute at 14.699 seconds after jumping, and at this time she is 3941.2 meters above the ground. Okay, so again, now let's use GeoGebra to check. So I've got the two equations here. So you can see what's happening in this equation, right? It's like she's falling really, really rapidly when she's in free fall, and then she opens her parachute and she just glides very slowly until she hits the ground, like 20 minutes later. Where do they cross, right? So we're going to type intersect H and G, and they intersect at 14.7 seconds, which is exactly what we said, and at a height of 3941.2. Now importantly, they also intersect over here at negative 13.88, which we also said. Of course, in our case, the model that we're using, the model is only the positive side, so we rejected this other point of intersection. Okay, so we only kept the one. Now, to end off today, I want to do one of the questions from the assignment with you. So if you want to open it yourself, you can. You can go through it with me if you like, or you can just you can just listen and then try it on your own after. So it says, a
cannon fires a projectile at a 45-degree angle, except it's going down the slope. The original position of the ball is 1 meters above the ground at the top of the hill. The slope of the hill is negative 0.47, and the projectile is fired with a velocity of 7 meters per second. How much horizontal distance does the cannonball travel before it hits the ground? Use the applet below to determine the equation to use in the question. So you don't have to figure out the equation, you just use the applet. So let's write down what we know, or rather use the applet. So my hill is supposed to have a slope of negative 0.47. So look here. So here's the cannon, right? It fires at 45-degree angle. The cannonball flies, goes down a hill, and then intersects the hill, somewhere down here, right? So my hill is supposed to be steeper than this. It's supposed to be negative 0.47. So let's bring it down to 47. So my hill is pretty steep, right? I'll zoom this out a bit so we can see better. Okay, so like the cannonball gets shot, it follows this path, and then it hits the ground, somewhere over here. Now my cannonball was also fired with a velocity of 7, so I'm going to change the velocity to 7. So you see, the information in the question, you just plug into the applet, and the applet will figure out the equation for you. Okay, so now we're going to show the path, and we're going to watch as the ball goes through the air, and then it reaches the ground. It looks like at about 1.61 seconds or something very close to that, right? I'm not exactly sure, but my answer is probably going to be pretty close to 1.61 because that's when it looks like the cannonball hits the ground. Of course, if I want to solve this, what I need to do is I need to take the slope, right, which is the equation of the hill, and then I need to take the equation of the path of the cannonball, and I just need to set them equal to each other the same way I would any other question. So the cannonball path, right, let's just call it P of x, was given by negative 1 over 5 x squared plus x plus 1. Okay? The cannonball, the slope of the hill, or the equation of the hill, let's say, let's call it h of x, is equal to negative 0.47x. Now, and it doesn't need a y-intercept because if you look at the hill, the hill just starts at 0, 0 and goes down with that slope. So all I want to do in this question is just work out when these two things intersect one another, right? So I would do this, so find the point of intersection. I would do this the same way that I would do any other question. So P of x is equal to h of x. When is the path of the cannonball equal to the hill? Okay, so P of x is negative 1 over 5 x squared plus x plus 1 is equal to negative 0.47x, right? Now I don't like working with negative 0.47, so let's multiply everything by 100. So negative 100 over 5 x squared plus 100x plus 100 equals 47x, right? So there you go. I just got rid of the decimal. I should keep it negative though. Okay, now that 105 I want to clean up. I know that's just equal to negative 20. And I get that equation. Okay, so negative 20x squared plus 100x plus 100 is equal to negative 47x. So I go ahead and solve this one. So to solve it, remember I bring everything over to one side. So negative 20x squared plus 147x plus 100 equals 0. And then I just use my quadratic formula. A is negative 20, B is 147, C is 100. Okay, so the equation that I'm looking for here, T is equal to, the quadratic formula, and I'm just going to plug in everything we know. So B, I'm not going to touch the negative, but I'm going to replace the B with 147. I'm going to replace B here with 147. I'm going to replace A with negative 20. I'm going to replace this A with negative 20. I'm going to replace C with 100. Okay, and you get that equation. So just to make this a little simpler, so our square root there, we get 147 squared
So 147 squared is 21609. So you can see there's a -4 and a -20, so they're going to be turned into addition. It would be 80, and then times 100 is 8,000, and then all of this is going to be divided by -40. Okay, so we're going to get two answers. So -147 plus square root 29609 divided by -40. Oops. Sorry, typed that wrong. Okay, and then the other one with the minus. So the exact same thing, but with a subtraction. All right, now quickly, what would those answers be? So we get -147 plus square root 29609 divided by -40. So one answer is -0.63, which obviously I'm going to reject. So let's just write this down. T equals -0.63, which we're going to reject is outside the domain. It's before the cannon fired, right? T is 0 is when the cannon fires, so we're not going to keep that one. Then let's do the other one, 147 minus. So same question. Just copy that, paste it, change this to a minus. And we get 7.98, which really does not look right to me. So I'm thinking I probably made a mistake here. Let me pause the video and just look for that for a second. Okay, sorry. It's the mistake is that I have set this equation up wrong. Okay, so let's just go back. Sorry, all the math is right. What's not right is what I think I'm finding. I found the answer, but I'm not finding what I think I'm finding. So let's just explain. The path of the cannonball is not the time. Look. T is 1.19, but x is 6 meters here. Our equation is not h of t, it's h of x, right? So it's how far, so x is how far it's traveled in a horizontal way, where y is how far it's traveled in a vertical way. And you can see that, yeah, actually it does land a little bit shy of 8, so probably my answer is actually right. So what I said at the beginning, where I said my answer would be 1.62, I'm totally wrong. I forgot that what we're looking for in this question is not how much time it spends in the air, but rather how much distance does it travel. And it travels, it looks like about, let's just try and get this as close as we can. It looks like it travels, just a bit shy of 8 meters, which, to go back to my question, my answer, it's not 7.8 seconds, it's 7.98 meters, right? So I'm going to say the cannon traveled 7.98 meters to the right before it landed. Now, the other answer of -0.63 meters is rejected because that is behind the cannon. Obviously, the cannon did not intersect the hill behind the cannon. I'm only going to take the answer that's in front of it. So I'm going to put in my answer of 7.98. Actually, well, let's just quickly check it before we do that. I guess I don't want to mess this up. So our question was -1/5x squared plus 1x plus 1, and then it was -0.47x, and we wanted to intersect f and g, and it intersects at 7.98. So pretty sure what we did here is right. So let's plug in 7.98 and see if we get the answer. Okay, so I'm going to submit this one. And we got the point, right? So when you're doing this question, don't make the mistake I did. You're not giving me the time. I don't want to know the time. I want to know the distance. So hopefully me making that mistake will avoid you making that mistake when you do it.
Okay, so that's everything we need about linear quadratic systems. Remember, sometimes there's no answers, sometimes there's one answer, sometimes there's two answers, and you're always making a related quadratic equation that's equal to 0 in order to solve.